Hello, I'm going to tell you a little bit about the periodic table. And see all this information in here? There's a lot of information in here. So I'm going to start with just the basics and tell you how to read it and a little bit about how it was developed. First of all, this is Dmitri Mendeleev. Dmitri Mendeleev was a physicist. He's an early physicist, and you can pause the video and get his name down because people are going to want to know his name when you're taking little things like SOLs. So Mendeleev and his buddies, they were working with atoms, and they had discovered the nucleus and the protons, and they wrote down all the information. They had the atomic number, which is the number of the protons and electrons. They gave all the elements a symbol and a name. And underneath there is atomic mass, and that's what's on all those cards or tiles that you see on a periodic table. So Mendeleev had like a deck of cards, and he started laying them out according to how many protons they had and how many electrons they thought they had. How do we get to know that? Because we can't see them with a microscope. We might be able to see some shadows now, but way back then, when Mendeleev was doing this, we didn't have a way to do that. But it was the way that atoms acted that they got the idea of how heavy things were, and they did a lot of experiments. And they knew that every single element had a certain number of protons in the nucleus. And that's what made this element what it was. It's why hydrogen only has one proton and helium has two. So he was laying these cards out and putting them in little families and groups and things like that, and he noticed patterns. So when he did it, there were only 16. You don't need to know that. But now that we know that there are 92 naturally occurring elements and a whole mess of other ones that are man-made, they came up with this. There are three basic types of elements. There are nonmetals, which is hydrogen, and all of these that are on this side of, hey, look, it looks like a staircase. Do you see that staircase there? That's important. You're going to have to remember that. And so there are nonmetals, there are metals, and there are metalloids. Okay, three basic types, and I'm going to talk you through a few of these things. This are rare earth metals, and they fit in here somewhere, and that's why you see little arrows coming on some of the tables. And that's high school stuff. Transition metals from here all the way over to here, and those are all going to be discussed and played with in high school. So what you really need to know is that there are nonmetals, metals, and metalloids. So one of the things that I need to tell you about is that metals have certain properties. And that's how we know they're metals, because, and you don't need to read all of this, because I'll read it to you. Metals are good conductors. That means that that electricity can go through them easily. Metals are shiny. Metals are ductile, and I'll talk to you about that in a minute. Metals are malleable. Talk to you in a minute. And a chemical property of metals is reaction with water. So corrosive. If you get certain metals wet, they break down. And we're going to get back to that in a minute. But here are two properties of metals that you need to know about and what they mean. So malleable, you can pause your video and write this down. Metals are malleable. They can be pounded into thin sheets. So think about aluminum. Aluminum is an element, and it's in thin sheets. It is malleable. Now, how you can crinkle it and all that good stuff, malleable. Okay, and pause this if you don't have it. If I'm going too fast, just pause it. Ductile. Ductile means that you can pull it into thin wires. So that's how they make copper wiring for your house, for electricity and things like that, because they're good conductors. Ductile. Okay, those are two properties that you really need to know about metals. Okay, we're only going to study certain metals this year in 8th grade. In high school, you're going to learn a lot more about transition metals and their atoms, things like that. Now, the nonmetals, a lot of them are gases, but some of them are solids. So nonmetals are poor conductors and are used, and so you can't put electricity through sulfur. Nonmetals are, some are ductile and malleable, some are not. Solid nonmetals are brittle and they're dull. Most nonmetals are gases. Some of them are solids. So here's what brittle means. You can pause and get to know what brittle means. It means it breaks easily. That's all it is. But you're going to need to know that vocabulary. Okay. Third one is metalloids. Remember this staircase? That's the border between the metals and the nonmetals, except for hydrogen. And we're going to talk about that. Hydrogen is kind of special. But properties of metalloids. Metalloids, they are metal-like, but they're not really metal. Some of them have properties like metals. Some of them have properties like nonmetals. They're solids, and they can be shiny or dull. They conduct heat and electricity, kind of better than nonmetals, but not nearly as good as metals. And they are ductile. They are malleable. So here's an example. Silicon is a metalloid. So here's what you really need to know about metalloids, is that metalloids have properties. They're substances with properties of both metals and nonmetals. All right, again, I'm going to point out that the metalloids, there are not nearly as many of them as there are metals, and they form a staircase. Everything to this side of that staircase is a non-metal, and everything else, if it's not a metalloid, it's a metal, except for hydrogen. Okay, so we've done a little bit about structure, atom structure, and the atom structure is going to take a big front seat in elements families. So everything in this family, they go in rows. Okay, families go in rows, and they have similar properties. So everything that goes up and down here, that's going to be very reactive alkaline earth metals. Okay, all the way over, it's going to become less and less reactive, to over here, we have noble gases, and these are the most stable element. Are these elements in this family? They're found with, they're never a compound. They're never together, they're always just their atoms. Okay, we'll look at the names of those, but one of them is neon. Neon is yes, the stuff that goes in neon signs. That's a pure substance, the stuff that glows. And then we have periods. You know how geography has a latitude and longitude? Well, chemistry has families and groups and periods, periodic table. So here's the periods. The periods go this way, and they tell you, and this is going to be a word that you need to know, valence electrons, and we're going to talk about that in another video. But the periods go in rows, and they're telling you how many valence electrons. So how many electrons are buzzing around the outermost shell of an atom? The outermost shell of an atom is called the valence electron. And that's important in the next unit when we talk about bonding. So we need to know that. We need to know how many valence electrons are in any given atom. So that's how Mendeleev found out if there was a gap, there was, say, 26 protons in some